All right, yeah, it's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic, we're going to write a function that has certain situations in it. Now, we've already talked about our vocabulary of asymptotes. We also have what's called holes in our graph. That's where if I was going to graph a line, like say I have this lovely graph going on, and maybe this spot right here I can't have, that x value might give me a hole in the graph, and then I need to know the y value. Okay, so we can have holes in graphs. Okay, those are values that are garbage in our calculator. So with that in mind, we are actually going to go about how to create one that does that. Now, what we need to do is first we need to remember that we have h or x minus h is the factored form of a root. And I'm going to give you the roots, and you're going to have to put it in factored form, and then we're going to do a little bit of math magic on it. So what do we have to know? Zeros are always in the numerator. Okay. Vertical asymptotes, those means they go up and down, are only located in the denominator. Okay, the factored form is only going to be in the denominator. And holes are in both the numerator and the denominator. So now let's look at this example. Write a rational function form is given the vertical asymptotes in 0. Okay, I'm going to have a 0 of x equaling 1 and a hole where x is equal to 4. Now using this information that I just told you up here, this information here, I'm going to write my function. This one here. Well, that says that I have x equals 1, so if I subtract 1 from both sides, oh look at that, if I subtract 1 from both sides of that, I have my 0. Or I could just take the 1 and stick it in place of the h up there. And the h, x minus h. So x minus h. There's my factor for 0. Undefined. Find the factor for the undefined. Well, x is 4. I'm going to stick it into my formula of x minus h. And I get x minus 4. Now, let's write the function. The function f of x is equal to, well, the 0 has to be in the top, x minus 1, okay, and the whole has to be in both the top and the bottom. And now I want to write it so that it looks in its polynomial form. So that would be x squared minus 5x plus 4 over x minus 4. And this is the function that has those characteristics. 0 of 1 and whole of 4. Let's try one more, and after we do this, I will be signing off and you'll be able to start on your homework. So, again, I have a vertical asymptote at x minus 1. Okay, I still have to find the factored form, so x minus h. Okay, well, I could rewrite that as x plus 1, as the two negatives make a positive. A 0 and 1, so this is x minus 1. And another one at negative 2, so this is x minus negative 2, or x plus 2. And it's defined for a whole at 4, so this is x minus 4. Now, we need to remember which ones go where. Okay, wholes are both top and bottom. Okay, zeros are only top. When I say top, I mean the top of the fraction, the numerator. And vertical asymptotes are only in the bottom, or in the denominator. So, let's put them where they need to go. All right, top and bottom. X minus 4, x minus 4. Okay, strictly bottom. X plus 1. Strictly top. X minus 1, x plus 2. There's my function written in factored form. The question is, do I want you to write it in factored form? No. I'd really like to see you do all that lovely multiplication out. And so I'm going to tell you, you have to do all the multiplication out, but I'm lazy because I'm a teacher and I have a high school diploma. We'll just do the box method. Right. First, you're going to believe me. The only one I have to do the box method is for x minus 4. So I'm going to do this polynomial here, which becomes x squared plus 1x minus 2 with x new numerator becomes x cubed minus 3x squared minus 6x plus 8 over x squared minus 3x minus 4. And there's my function. All right. I'm going to give you a homework sheet. You're going to work on it. You're going to write down your questions, and you're going to bring them to class for tutoring, and we will then answer them. Take care. Have a wonderful day. I know y'all can do this. You are awesome.